Hi, this is Sue, and we're going to do a little more of 3.1. So all I want to do in this video is talk about the notation and some basic rules. So the notation is here, and some of this notation we've already talked about. So if you have a function y equals f of x, you can write the derivative as f prime of x or y prime. These are both called Lagrange notation after the mathematician Lagrange. But there's also another way to do it, which is important that you know. I'm going to skip all the way over to the right. This is the Leibnitz notation. So Leibniz would write it as dy dx is the derivative of y with respect to x. It looks a lot like the slope formula of delta y over delta x, right? But instead of a delta, you've got a d. So this was the Leibniz notation. You can also think of this as, since this is the derivative of y, sometimes people think of d dx as an operator. d dx means the derivative of. Just like a square root sign is an operator. It says take the square root of the thing inside. d dx means take the derivative of the thing that comes to the right. So you will also see it written this way, d dx of y. So that means the derivative of whatever y is. You might also see d dx of f of x. You also might see, d dx of anything. d dx of sine x means the derivative of sine. So I want you to be comfortable with both of these notations. So this is the derivative function. If you want to do the derivative at a particular point, we remember that a derivative at a particular point is a number, right? Like the derivative at x equals 3 might be a slope of 7 or something like that. And we just plug it in. So that would be f prime of c would be a number. And in the Leibniz notation, we write it like this, where this vertical bar is called an evaluation bar. And we say that this is dy dx evaluated at x equals c. So you'll see this and you'll have to use this as well. So just remember that vertical line means that's an evaluation bar. And down here on the right, you put what is the specific x value. So you might see something like find dy dx evaluated at x equals 4. Okay? Also, in the future, we're going to be taking the derivative of the derivative. Super fun. The derivative of the derivative is called the surprise second derivative. And you, with the prime notation, with the Lagrange notation, you just make a double prime. With the Leibniz notation, what you're actually doing is you're taking y and you d dx it to get the first derivative, and then you d dx that to get the second derivative. So we usually compact that notation into this notation. We read it as d squared y dx squared. And it's sort of like what I wrote here in green, because there are two d's on the top. It's really not a d squared. We're not multiplying. But this is just a way of writing it in a compact way. So d squared y, and then on the bottom there's a dx and a dx, so we write that as dx squared. But I really want you to think about this as the second derivative of y with x as the independent variable. So that's it for notation. There are a couple basic derivative rules I want you to be familiar with. So we've talked about some of these. If you have a function that's a constant function, we've said the graph is a horizontal line, the slope of a horizontal line is 0, the rate of change is 0, it's literally not changing, and f prime will be 0. So we're going to treat this as a rule that you no longer have to explain or use the limit definition for, it just is. There's also a rule for the identity function, and we proved this in the beginning of this unit, that if your function is x, then the derivative of that function is 1. The constant multiple rule says that if you have a function that's being multiplied by a constant, and you want to take the derivative of it, what you can do is take the derivative of f of x and just multiply it by that constant. So for example, if you were trying to take the derivative of 2 times tangent x. Well, we don't know how to do that right now, but we do know that if I knew the derivative of tan x, I could find that and just multiply it by 2. Okay? So the derivative of 2 times the function is 2 times the derivative of that function. This will be extremely useful. And the sum and difference rule says if you're taking the derivative of 2 functions that are being added or subtracted together, you can just take the derivative of each part separately. There are ways in which these are similar to the limits rules that you learned last year. Derivatives are more complicated than limits, but it's unsurprising that there's similarities. So we will work with these soon.